Solar and wind power plants may help reduce climate warming. They do not produce the massive amounts of CO2 that conventional fossil fuel plants do. But their electricity yield is highly variable because the sun's intensity and the wind speed change with the weather. Germany's wind energy turbines could supply 10 cities the size of Berlin with power if the wind was blowing constantly. This facility strikes the balancing point between the electricity being fed into the grid and total usage. The engineers here constantly adapt the energy generated to actual demand so as to prevent overloading the grid. They're helped by a system that predicts how much wind energy they're likely to make over the next 24 hours. The blue line shows the wind energy produced during stormy weather. It was much higher than predicted values, and it rose suddenly.
You can imagine that this puts an absolute strain on the system itself, and it makes it a huge challenge to adjust for these processes. It's as if you were constantly turning entire units of a power plant on and off at short intervals. It's a big challenge.
As the proportion of wind and solar power in the energy mix rises, the difficulties of balancing the power in the grid with demand have also grown. Reliable weather predictions are playing an increasingly important role. Researchers at the German Aerospace Center in Munich are developing those kinds of prognoses. They specialize in supply-demand predictions for solar energy plants that concentrate the sunlight and use the heat to make electricity. They're currently working on prognoses for Andasol in southeastern Spain, Europe's largest solar thermal power plant. Unlike facilities that use photovoltaic cells, these power plants convert direct sunlight into heat and then into electricity. That means anything that darkens the light has a significant effect on the plant's output. The Munich meteorologists factor in clouds, but also fine particles in the air, so-called aerosols. For their predictions, the scientists need to know precisely how much the different types of clouds and particles reduce the incoming sunlight.
It's the same with both clouds and aerosols. They have very different values of what we call optical density, depending on where they're coming from. A dust particle has different properties from a soot particle, and we have to know what's actually in the air at any given moment.
Satellite images are a big help. Meteosat, a European weather satellite, provides valuable data. Its images show the distribution of clouds and aerosols and how fast they are moving. The satellite provides a new picture every 15 minutes. That allows the researchers to predict irradiation levels for the upcoming hours. These pictures show a dust cloud on its way from the Sahara to southern Spain. Combining the images with other data from the satellite, the meteorologists have created a computer simulation of how the dust cloud is spreading. The different colors show how much the dust blocks the sunlight. These cabinets contain satellite pictures from the past 3 decades. They're a treasure trove of information from the energy meteorologists. Using the images, they can reconstruct how much sunlight reached the Earth over the years. Based on that, they can see where it's worthwhile to build solar energy plants. Maps show the energy yield at the Mediterranean over the period of a year. Amounts of sunlight were highest in the yellow regions. This basic research is geared toward realizing a vision. Called Desert Tech, it foresees giant solar power plants that would provide Europe and Africa with climate-friendly electricity.
What that means for us is that we're able to describe the aerosol aspect much more precisely, because Desert Tech will also be focused on the North African region, and there's more dust from the Sahara there.
The scientists soon hope to be able to predict energy yield up to 2 days into the future. That would allow wind and solar power suppliers to distribute electricity as efficiently as possible, saving money and protecting the environment as well.